Hi, I'm Stevie C and the place to be. Some things have arrived in the post from China, namely some flashing LEDs and some circuit boards from JLCPCB, including BigClive's Gallium boards, but they're for another video. In this video, I'm going to be taking a break from my far from perfect PCB production efforts by assembling my Jojoba Bunny PCB. If you're wondering, Jojoba is a half-watt bunny I follow on Instagram. I'll stick a link in the video description text box. Here's Jojoba and me sharing a carrot. So as always, I used Sprint Layout to design the board. I liked Layout 50 for the reasons that BigClive extolled, that it was easy to start slapping tracks and pads down and getting torn into a design. I used the scan image function to import Jojoba's logo and lay circuit tracks on top of it. I do have BigClive to thank for helping me get my head around the Gerber export process. However, I made a schoolboy error by failing to double check some of the component-wide drill sizes generated in the software. As you'll see with this board, the bridge rectifier doesn't quite fit. So I remedied this just by redrilling the holes with some 1mm tungsten carbide bits. So in this one, the bridge rectifier now fits the board. So from my schematic, you can see that I have two circuits of LEDs for different parts of the bunny, both driven from a 240 volt mains supply with a capacitive dropper. The LEDs I'll be using are these 3mm RGB slow colour changing through hole ones. I got caught out in one of my previous videos by stating that an LED had a forward voltage of 2 volts when it was 3 volts. I was just going by the datasheet supplied by the manufacturer. That was wrong, so I made the mistake in the video. I have since corrected this. But just for simplicity, I'll be assuming that these LEDs drop approximately 4 volts, so that's what I'm going to use in my calculations. The forward voltage will waver depending on what colour it's actually doing, but 4 volts is a good average to go with. So depending on how many LEDs I'm driving, whether for the back part of the rabbit or the front bit, I'll be using either a 100 nanofarad or a 220 nanofarad dropper capacitor with a 1 megohm discharge resistor. I'll be using an inrush limiting resistor between 100 ohms and 1 kilo ohm. I'm just making this up as I go along. I've got a full wave bridge rectifier and an electrolytic capacitor for smoothing. So to work out the drive current for the LEDs, we'll multiply the number of LEDs by their approximate forward voltage. In this case, 272 volts that will be dropped by the LEDs. Because I'm using a full wave rectified and smooth supply, we use 330 volts. Take away the voltage dropped by the LEDs, and we're left with 58 volts to be dropped across the capacitor. So in this case, I'll use a 220 nanofarad capacitor. We divide that by the equivalent series resistance of the capacitor, in this case 14,468 ohms. It's 1 divided by 2 pi FC, I just worked out beforehand. We get a drive current of 4 milliamps. Likewise with this circuit, again it's 45 LEDs times the 4 volts, 180 minus 330. And in this case, I'm using a 100 nanofarad capacitor. So that is equivalent to 31,831. So that gives us about 4.7 milliamps. So yeah, 0.7 milliamps of difference. I don't know. That'll be fine. So I'm going to start by soldering in the resistors on the power supply section. You'll notice I've opted to use half-watt resistors because these are rated for our mains voltage, whereas the 250 volt quarter-watt resistors I originally used in the design obviously aren't rated for our mains voltage. I've also opted to use 470 ohm resistors for inrush limiters. It'll either go kablamo or it'll work as usual, so we'll see. So now it's time to solder in the rest of the power supply components. So after much fault finding on an isolated 120 volt supply, it's now time to find out if it will work on a 240 volt supply. So will it work or will it go kablamo? Place your bets now. Okay, it's pulling about 2.3, 2.4 watts. 0.7 of those watts will be the neon in the quick test. 10 milliamps, give or take. So there you have it, my Jojoba Bunny PCB with slow colour changing LEDs. As you saw, my design could do with a bit of revision. I'll possibly add discharge resistors across the electrolytics, and of course I'll remember to specify the correct drill hole sizes for the components. Version 2.0 is going to have Jojoba's name spelled out in LEDs down the side to help fill out the space, and hopefully hide all the horrible mess behind. And as I said, I was using an isolated 120 volt supply when I was fault finding. I may have killed a few LEDs by keeping the iron on them too long. Blame my shaky hands. And as I said before, I'll stick a link to Jojoba's Instagram in the video description text box. So fault finding aside, I thought that was very good for a first time prototype. So all that remains to be said is like, subscribe, wash your hands, leave suggestions for future videos, and I'll see you next time. Thanks for watching.